in object/sphere object 1. I changed from the scene to the geometry context where I build my geometry. So I got my sphere, and I'm going to go here and drop down a box. I'm not dropping it down a box now in the object world. I'm dropping it in the geometry context because I'm building one object. So type in the word box, and I dropped it down, but I don't see it. So let's take a really close look at these nodes for a second. So you notice on the sphere node, and I'm even going to go closer on the sphere node so you can actually see the little icons. There you go. You see that there's these flags, a blue flag, a purple flag, kind of an orangish reddish flag, and a yellow flag. Okay, and the rightmost is your visibility flag. Kind of looks like an Adobe Photoshop eye for a layer. If I turn it off by selecting another object, let's say the box, the visibility is on the box and not the sphere. And likewise, if I go to the sphere and turn it on, I see the sphere and not the box. If I need to see both, let's put the visibility on the box, the next flag over is the template flag. And I turn that one on, and now you can see I see a kind of a grayed out or wireframe of that sphere. Cool. Now, let's look at that sphere in more detail. I want the box to be on top of the ball, but the first thing I don't like about this ball is it's halfway above the floor and halfway below the floor. So what I would like to do is make sure that the ball is always on top of the floor. So when I click on the sphere, I look in the parameters view here, and it has the radius. And what I was just doing here is if I middle click on the label here, we get what's called Houdini's value ladder, which is quite unique to Houdini. And as you can see, what's really nice about it is it moves in orders of 10. So I can scale in single units, in tenths of units, in hundreds of units, whatever refinement I need. So right now I have a radius of 1.5, 1.5, 1.5. So sure, you guys are quite smart. If I just move my center to 1.5, that means I'm moving it in the y-axis by 1.5 units, and therefore it's going to be on the floor. And that works, but we're back down to kind of that old static metaphor of modeling that we do in other packages. What would be better is if I could dynamically do this. So if I change this radius, I don't break the system. So all I'm going to do is go to the Y channel and right-click on it. And when I right-click on it, it gives me all these options. And I can say Copy Parameter. And I'll left-click on that. Now, what did I just do? If I hover my mouse over the radius, you'll see that there's a tooltip that shows up. And it says there's 3 parameters for the radius, rad x, rad y, and rad z. So those are the variables that hold the radius. And so when I right-clicked and say Copy Parameter, I copied rad y. Now what I'm going to do is go to center. I'm going to go right-click again, and I'm going to say Paste Copy Relative Reference. And lo and behold, an expression shows up. And I know if you guys can see on my screen, but now it's light green also, showing that there's an expression on this channel. And what this is saying is I want to look up a channel. What channel do I want to look up? The guy called rad y, okay, which was up here. So now when I adjust my radius, no matter how I adjust it, it gets updated in my center Y channel, and I always stay on the floor. And if I want to verify this, all I have to do is left click on the center label, which toggles between the expression and its evaluated value. So you see, no matter what I do here, it's going to update to the same value down here. I toggle left click again and toggles back to that expression. Cool? So I get a text that says, if you guys can hear, I don't know what to do. Can a majority of you hear? Just texts. Let's see who can hear. So it looks like a majority can hear. I really can't help those who can't hear, but we'll be posting this afterwards, so I do apologize. Again, either try to call in again or set up your computer to go through the computer audio. So I'm going to continue on our merry way. So now I got this ball that's on the floor, and I want to put the box on top of the ball. So before I do that, let me show you how to work your way around the scene view a bit. So I want you to notice that right now I have the scene here. As soon as I hold down the space bar key, you'll see it temporarily changes to view. Let go of the space key. So it's toggling between kind of tool mode and view mode. When I hold the space key down and left mouse drag, I can orbit my view. When I hold down my space key and right mouse drag, I'm zooming in and out, and my middle dragging with the space bar, I am panning my view. Okay. Now, a lot of beginners enter this problem where they're thinking they're manipulating geometry and nothing's happening. Their screen is looking kind of wonky, it's orbiting around. And the reason for that is you're going to be permanently in view mode. And the way you accidentally do that, on purpose do that if you want to do it, is if you hit the escape key, notice it toggles to view mode permanently, and now I don't have to hold down my space key at all. And to get back to tool mode, all I'm going to do is hit the return or enter key. Okay, so escape gets me into view mode, return gets me into the tool mode. But again, most of the time, all you're going to do is hold down the space key and use your mouse buttons to temporarily get you into view mode. Cool. So now I got my sphere here, and I want to get my box on top of the sphere. So I'm going to turn the visibility onto the box. And actually, I want to see both of these together at the same time. So what I'm going to do is I'm going to drop down another node, and that node is the merge node. So I'm going to hit tab key here and go MERGE, and there it is. Left click on it, left click it onto scene. And what I want you to notice when I zoom into the merge is, unlike the other nodes, which you'll see these little boxes on top of and below the box node is your input context and your output context. They have one triangle each. This one has 3 triangles, which represents that you can put multiple inputs into it. So the way I wire nodes together is I left click on the output context once, and you'll notice a wire comes out of it. Then I left click into the input context that I want, and I get a solid line. And likewise, left click, and I merge them together. And I really still don't see anything different because the visibility flag is on the sphere. Now I'm going to move the visibility flag to merge. And now I see both of them. Okay? And to disconnect it, all I do is right click on the wire and say disconnect. I'll reconnect it because that's what I want. There we go. And so now I got a sphere on a box. But now I want this box to go on top there. So let's look at the box parameters. Well, I don't have a radius, but I have a size. Okay? And a size is basically a bounding box, so it's the full length, or you can kind of think of it as the diameter. So I could right copy this like you've learned before, and I could paste it like you learned before. Or another technique I could do is just highlight this number and left mouse click and drag. And you'll see my icon changed. I just let go, and I'll get this pop up here, and I'll say I want relative channel reference, and I get the same thing. Okay, so let's look at where the box is now. The box is not on the ground, so you notice I changed the visibility from the merge to the box. It's hovering above, because remember the center point of the box was right here, and we were halfway below, but we're moving at the full diameter. So an expression is an expression. I'm just going to say divide by 2, and now it's on the ground. Wonderful. But now I got to go and get it on top of the sphere. Well, I already know what the sphere's expression is, channel rad y. So why don't I just go to the box and make my high school math teacher happy by putting in the parentheses to make it look nice. And say, let's add that channel. Then go plus channel rad y. And notice I'm putting it in quotes because it's a string value. And I'll hit return. And nothing happens, but worse yet, I get this warning. That's what these yellow hazard lines are. Well, why are we getting this warning? What I haven't told you yet is that Houdini is a true file system as far as its geometry, its particles, and everything. If I just quickly toggle back to the technical desktop, you'll notice here's a tree hierarchy. And you'll notice that the object is just a folder to put in other things like cameras. And here's my sphere object you created, and it's just a folder that has a box emerge in a sphere. Okay, so just like if you're shell scripting or doing some HTML and go image source equals ... to get to your file, it's the same thing. My sphere is a file, my emerge is a file, my box is a file. My sphere object is a folder that contains all this stuff. My object is a folder that contains all this stuff. So I'm going to go back here, Window Desktop, to build. Okay, and so I got to say, where is this actual channel rad y? Quite easy. I'm going to say, just like in shell scripting, ... to get me up one level in my file hierarchy. Look for the sphere 1 node, because that's what it's called here, sphere 1. And in the sphere 1, I'm going to see a channel called rad y. And let's see what I misspelled. I call this F here. Let's just delete that HE right here. And voila, it jumps up. So now if I merge them, well, it's almost there. I'm going to show you in wireframe mode so you can see it a little better. It's almost there, but remember the sphere was only a radius. So guess what I got to do here? I got to multiply it to go to the top, which is the diameter. So I'm going to multiply it by 2. And again, make my high school math teacher happy by making it really nice and clean. And voila, now I see a box on top of a ball. Now I'm going to switch this back to smooth shaded, and let's see how robust this system is. I go back to my sphere node, and let's change the radius. And look at that. My ball remains on the floor, and my box remains on the ball. Let's change the size of the box. It always remains on it. A much better system than having to constantly redo the entire model. Okay, so can we animate this? Sure. So let's take this sphere, and now you'll notice on my timeline I'm on frame 1. And what I'm going to do is I'm going to make this radius real small. And to do a keyframe, a traditional keyframe, all I'm going to do is hold the Alt or Option key, depending if you're on a Mac or PC, and left click on the label. And you'll notice that all this turns to green, indicating a keyframe has been set. Then as soon as I move my timeline anywhere else, you'll notice it turns to kind of this light pale blue, indicating that there's a keyframe on the parameters, but not on the specific keyframe, or the specific key. So let's go up to frame 72 or 73. There we go. And now I'm going to increase my scale again, like that. And notice it's yellow, saying that I've changed the values. And I'll Alt-left key again to create a second keyframe. So now if I go to my timeline and reset to frame 1 and play, voila, I have an animation, the box remains on the ball. So that's keyframe animation. How about procedural animation? To do procedural animation, let's look at the box. So here's my box, and I'm going to go here and let's just write an expression. I'm going to write sign, $, capital F. And I'll say times 6. Now, everyone knows what a sign function is. It's a value that cycles between negative and 1 periodically. So we should see things growing and shrinking. And then what is this expression in between? Well, the argument that goes inside a sign function is the frequency. But what is this $F? Well, whenever you see a $sign with some capital letters afterwards in Houdini, you know it's a variable that's kind of built into Houdini. And what this one stands for is frame number. So let's take a look at it. I'm just going to wipe that out for a second and just go $F. So I'm on frame 1, and you already learned that if I left click on the label, it will toggle to show me the evaluated value. And sure enough, frame 1, $F says it's evaluated to 1. I move this to, let's say, 45, you notice that it automatically moves to 45.2 here. So $F just reports the frame number. Cool. So now let's go back to sign $F times 6. And let's get rid of that $F. There we go. And let's see what happens now when I animate. There you go. So traditional animation versus keyframe animation versus procedural animation. So we just finished our little baby exercise. Let's move on to something more interesting. So what I'm going to do is I'm going to go up one level, and I could click on here to go back to my object level, or I can hit the U key, which stands for going up, as my keyboard shortcut. And I'm going to call this, by single clicking I should say, right on there, I'm going to call this box on ball. Cool. Now what I'm going to do is I'm going to try a new thing. I'm going to create a procedural forest. Okay, and hopefully in 10 minutes I'm going to create a whole forest for you. So what I'm going to do is I'm going to drop down a new node, and it's going to be called a geometry node right here. Now, let's go up. Sorry about that, just double clicked accidentally. So now at this geo level, okay, I could turn off the visibility flag, but I really don't care about this right now. And I'm going to call this forest. So I have two projects all within one file right now. And you'll notice by default when I drop down a geometry node, I get this little box here, which represents once I go in, and the keyboard shortcut is I, or remember, just hit double click the mouse, is a file node. Because a lot of you guys are modeling in other packages like Maya or 3D Studio Max or Modo. So this file node is there by default, so you can input geometry from other packages. But today I don't need that, so I'm just going to delete it. And I'm going to create a forest for you. So every forest needs some terrain. So how about a grid? There's my grid. And I'm going to zoom out a bit so you can see it. And I'm not going to need a construction plane today. So what I'm going to do is, on this strip here is all kind of your flags and visibilities. So I'm going to turn off the construction plane. And there it is. And what I'm going to do is turn on, just for now, smooth wire shaded so you can actually see the grid. And I'm going to change the size to 50 by 30. Why not? So I have a decent sized terrain. And then I'm going to go rows 30 by 50. And the only reason why I'm doing that is so my rows are perfect squares again, easier to visualize. Well, it looks like a pretty sucky terrain. It's perfectly flat. It looks more like a sidewalk. So now what I'm going to do is I'm going to drop down a mountain SOP. And the way I could do that real easy is, instead of hitting tab right here, like we've been doing, if I just right mouse button right on this output context here and type the word mountain, and then hit return, you'll notice that the wire connecting the two automatically is created for you. And I'm going to turn the visibility from grid to mountain. And yeah, that still really doesn't look like a good terrain. It kind of looks like dried mud or something like that. So what I'm going to do is I'm going to change the height to maybe something like 4 or 5, whatever you guys like. $10 a bit high. 5. And I'm going to lower this frequency, and I'm going to go into the hundreds and really lower this down. And I'm sorry, guys, but because of the recording, my computer's a little sluggish. And until I get a terrain that I like. That looks pretty good. So I just lowered the frequency. The mountain SOP is basically just a 3D fractal generator, noise generator. So I really lowered the frequency to give me this kind of natural looking terrain. Not bad. Okay, well, every single terrain to be a forest needs trees. And we all know that it's better to work with low poly count proxies to start off with. So my trees are going to be boxes. So I'm going to just drop down a box. I didn't hit the right click. I just wanted it separately. And what I'm going to do here is I'm going to use my favorite SOP, which is the copy SOP. And this is really, when I started learning Houdini, what convinced me to switch packages and go to Houdini. And we'll see the strength of it shortly. And if I middle click on an input node, it will tell me what it wants. And here it says primitives to copy. So I want to copy my trees, these boxes, right here. And then the middle click here says, what is the template to copy to? And I'm going to use the mountain. So what it's going to basically do is going to copy a box onto every point. And let me show you this. Flags for the points. There are my points. There you go, the blue dots. So it's going to copy a box onto each of these guys. I just changed the visibility flag, and lo and behold, I got this wondrous thing of boxes. Well, they're kind of large and squeezed together, so what I'm going to do is right-click outside on the bottom of the box and say Transform. And this is where you do your translations in the geometry, your scales, your rotations. And I'm just going to say, let's lower the uniform scale a bit so we can actually see the individual boxes. Oh, cool. I got a forest of boxes. Be patient with me. It'll become a real forest shortly. But what's our problem? I'll go to the top view, and you can see there's a box uniformly spaced on each point. So what I would like to do first is not have this kind of, Christmas tree lot of trees. I would rather have trees randomly spaced all over this grid. And to do that, I use what's called the scatter stop. So right underneath the mountain, I'll hit the scatter stop. I'll drop it down, and lo and behold, it generated 5,000 trees right off the bat, and you can see it's no longer on the grid. Way cool. Okay, but I don't need that. Let's start with 500. And you'll notice that right now, just temporarily, the ground is gone, but that's okay. So I solved one of the problems. I now randomly distributed trees all across the terrain. Okay, so what's the next problem? The next problem is, well, I did that, but they're all the same size. And I would like to kind of have, mature old trees that are large and saplings that are small. So let me show you something that's really unique to Houdini. And that is being able to create on the fly your own attributes. So I'm going to go here and Attribute, and I'm going to drop down an Attribute Create. Now, what is an attribute? For those who have a programming background, it is like a variable on the fly, attaching one in an object, a dynamic variable. For those who don't have a programming background, you can think about it as when you buy some clothing, there's the sales tag on it. It's something that just gets attached to an object and goes along for the ride, and we can use it whenever we need. So I got this attribute create, and I'm going to say p-scale under its name. And when I do that, notice all the boxes are gone. Now, what is p-scale? It stands for point scale, and basically every point has a weight to it. And therefore, when we do the copy, it knew by default that the default weight is 1. We multiply a box by 1, it's the same size. But look at the value right now. The value right now is set to 0. I changed this to, let's say, 0.3, and now I have all these little small boxes. Cool. But now I want to paint in my sizes. So I'm going to, right after the attribute create, right-click again, and say Paint. And I'm going to drop down a Paint stop. Now, for those of you from other packages, what do you use Paint for? Well, normally you use Paint for to either apply color to your object or your geometry, or if you're in rigging, to say what is the strength of binding to a joint or bone. But one of the key tenets of Houdini, if you ask me, is data is data. Houdini doesn't care if it's a particle, if it's a dynamic simulation. It's just data, and it's your job to manipulate that data. So in this paint stop, what I'm going to do is go right over here, and I'm going to say override color. And by default, you see the colors variable is CD, diffuse color, which makes sense. You want to paint color. And I'm going to change this to p-scale. Cool. Now what I'm going to do is, if you see my mouse over here, there's a little red circle. That's your brush. If I hold down the Shift key and left drag, I can increase the size of my brush. And let's see what happens. As I'm brushing, you can see that my trees are growing. Right now, the merge mode for the paint is in replace. Let's do an add. So now every time I go over it, I'm adding to the scale, the point scale, and I could actually paint in what size I want my trees. And so if I change this RGB value, now RGB doesn't really mean anything, even though in Houdini color goes from 0 to 1. I could change this to a 5 because data is data, and now I'll just really start to get big old growth tree. Let's put one really big one in the center there. There we go. Okay, and so now I have really cool boxes for my terrain. So I already solved two problems. I solved the distribution of trees on my terrain to scatter them around, and being able to paint in very quickly the size of my trees. Now let's add some trees. So that was my low poly proxy. So I'm going to just drop down an LSystem, not connected to anything right now. An LSystem is a mathematical expression language for basically repetitive organic structures like trees. You'll learn that in the future. But by default, there's one little tree by default on there. And all I'm just going to do is just going to bypass everything and stick that into my copy. And lo and behold, I got trees here. Okay, but it would be really nice if I was able to switch between my low poly proxy and my trees. So let me disconnect this, right click, disconnect. Cool. And I'm going to drop down a switch. And what a switch node is does exactly that. It switches between two inputs. So I'll put the box down, the LSystem down, and put this to my copy again. And now watch this. When I click on the switch, so here's my parameters, and I'll switch this from 0 to 1. There's my high, back to my proxy. Way cool. So, solve the scale problem, solve the distribution problem, but all my trees are oriented the exact same way. I would like to rotate them randomly too. So let's do that. Okay, so I'm going to do one last thing first. I'm going to merge. So let me kind of squeeze down here. Let me actually go like this. So you can see the full view of the nodes. Perfect. So this little box up here toggles me between the minimized view and taking over the whole window. So what I want to do is I'm going to drop down a merge and put my copy in the input here. And then go all the way up. I don't have to go to the last guy in the chain. I can go anywhere I want and click on the mountain and bring the mountain down and make that visible. And now let's see the view. And sure, now I can see the terrain and the boxes. So finally what I want to do is this random rotation of trees. So that's where I love the copy SOP. You'll notice that there's a second tab in the copy SOP called Stamp. And make sure to turn it on. Even advanced users forget to turn this on and say, what has happened? You got to turn it on. And you'll notice that there's a bunch of variables that I could declare. In fact, there's 50 of them I could declare, but we'll do one for right now. And you give it a name, whatever name you want to give it, and I'm going to call it tree rotation. TR, capital ROT. And I am going to give it an expression in the value. And that expression is going to be a random function. Now, a random function generates a number between 0 and 1. Okay, but it needs a seed value. And why it needs a seed value is so it knows to randomly create different things. And that seed value I'm going to create is called $capital PT. Like that. And one more try. There you go. So what is $PT? Well, you guys already know that if you have a $ with capital letters afterwards, it's some type of variable. In this case, the variable stands for point number. Let me show you what that means. Let's go back and select the mountain SOP. So I'm just making the mountain SOP visible. And we already saw that if I click on this, it shows me the actual points. But if I click on this with a little number, it will show me the point number. You'll see that every point on the terrain has a unique number. 727, 728, 729, so forth. And so we can actually use the numbers to generate unique random values each time. So back down. then merge, and I'll turn off the numbers. So now in my copy SOP, what I'm going to say is random $PT. So generate a random number for each tree between 0 and 1. And then I know there's 360 degrees in one rotation. So what I'm going to do is multiply by 360, and nothing happens. I created the variable, but I have not applied it yet. So I have to now go up to apply it. And what I'm going to do is right underneath the switch, I'm going to right-click and add another transform. This is where I'm going to actually transform all the rotations. And notice if I went to the Y channel rotate and said 45 degrees, all my trees rotated, but they all rotated 45 degrees, not randomly. So what I like to do is go here and say stamp. I want to call the stamp function, and it takes 3 arguments. The first argument is what node is that variable located in, and you'll notice that it says copy 1. So copy 1. Okay, and bad boy, there we go. The next one is variable is what is the actual name of the variable, and we call it tree rotation. And finally, the third argument says if I can't find it, what should I do? And I'll say rotate 0 degrees. Now you'll notice that all the boxes are rotated randomly between 0 and 360. And again, if I go to my switch, change it to 1, there's my forest of trees. Now what's really cool about this is, remember, this is all procedural. It's not like Maya where I have to constantly go clear all history and lose everything. Everything is still live. So I could go back to my scatter SOP right here and now change it to maybe 1,200 trees I want. And everything gets updated automatically. Cool. I got 18 minutes to show you one more example. I'm really happy that we're just going right through this. So I'm going to go up one level here. And I see there's a couple of questions. Please ask me after this webinar, and we'll go to the forum and I'll answer your questions for you. Or just stick around afterwards and maybe I'll be able to type a few of the answers right here. So, kind of drop down another geometry. And I'm going to turn off my forest. And this time I want to do a particle sim. And what I want to do is I want to create a sphere, and I want to emit particles going up north, up on the y-axis, and take on the shape of a teapot. Really simple for Houdini to do. So I'm going to call this example particle teapot. I'm going to delete that file because SOP because I don't need it. So I'm going to drop down a sphere. That's what I'm going to emit my particles from. Now, we're going to have a whole week dedicated to particles in this webinar, but for now, just know that particles need to be emitted from points. So I'm going to go into my parameters here and change it from primitive to polygon. And now you can see I have points. And if I middle click on the node, it gives me all sorts of information, including how many points are in this sphere. There's 42 points and 80 primitives. Now, a primitive is just a polygon, basically, in this case. But 42 points. Keep that in mind. You'll see it later. Okay, and I need to create a teapot for the particles to grow into. So in Houdini, a teapot is a platonic solid. So I'll drop down the platonic. And there it is. And let's put the visibility flag on it, and it doesn't look like a teapot. So all I have to do is go to my solid type here, tetrahedron, and go Utah teapot. Voila. And I'm going to change its radius to 2. So it has some size. I'm going to move it 3 up on the y-axis. So here's my sphere. The particles are going to emit from here and go and make a shape of a teapot. Way cool. So I want to create this particle network. So I'm going to go tab, POP, and you'll see there's a pop network. When I drop it down, you'll notice it's slightly different. It's got 4 little boxes instead of 1 box. Each of these boxes are called an input context. This is context 1, 2, 3, and 4. And right now there's a hazard. That's fine. It's just warning you. We'll see what's warning. And I'm going to wire the sphere to the first input context and the teapot to the second input context. and I'm going to dive in. And this is why there's warning. We have to tell it where the source of the particles are. So I'm going to drop down a source node, a source pop. And it's now has not that yellow hazard lines, it's got those red solid lines saying, I really messed up. And the reason why I messed up, let's see if you can see, cannot obtain the geometry of the specified SOP. So what I did was I just middle clicked and the error's on the bottom here. And basically it's saying is I don't know who the source should be. I'll go up to my geometry source in the parameter, and you'll notice there's a first context geometry. What's the first context geometry? Go up. It's what I wired to the first input. This would be the second input context. I'm going to turn the visibility flag on the pop net now. Cool. And I'm going to run my simulation. And let's zoom in a bit. And sure enough, you see these little white particles. They're being created, but they're not going anywhere. So what I'm going to do first is I'm going to set up my sim. I want to click on this guy right here, which is my real-time toggle, so my particles work on real time. And then I want to, 240 is kind of short for the simulation, so I want to extend my timeline. So what I'm going to do is I'm going to go here into my global animations options and change this from 240 to, let's say, 500 frames. And I'll hit the tab key and then hit apply when it gets highlighted. And I'll say, it's asking me if I want to stretch my keyframes. I have no keyframes, so no. And I'll close. And now I have 500 frames. And I'll run this, and you can see I'm creating the particles again, but it's not going anywhere. And the reason why it's not going anywhere is because if I look in my pop network at this source, I go into attributes. You'll see that by default, the initial velocity of particles is u's inherited velocity. Well, what is that speed of the ball going right now, that sphere? 0. So my particles are not going anywhere. So I'm going to go and change this to add to inherited velocity. And now I could give it a speed. I'm going to say I want you to go up in the 3 and the y in speed. And I'm going to also increase the variance, say 3, 3, and 3. So what is this variance? Basically it's saying, let's take this y channel. So I'm saying by default I'm going up to 3 units, Houdini units, per unit per second, and I say I could add 3 on some of it randomly, so it could go, the particles could go at a velocity of up to 6, or subtract 3, or no velocity at all. And likewise here, so this would be going from positive to negative 3, positive negative 3 on the x and z axis. So now let's take a look at our particles. All right, we got particles going all over the place. Way cool. Okay. But they're not forming a teapot. Why aren't they forming a teapot? We haven't told it who to attract to. So I'm going to go right click here, and I'm going to type attractor. And once again, I get this error because I didn't tell that I wanted to attract to my second context geometry. Now let's run this simulation. So I now told it to attract to the teapot, and nothing is happening. Well, there's 2 reasons why there's nothing happening. The first and main reason is I told it who to attract to. But think about the gravity of the Earth to the Sun or Pluto to the Sun. You have to specify what are those forces, and we haven't done that yet. To do that, I'm going to do 2 things. I'm going to go up here, and let's take a look at our teapot. Okay, let's turn the visibility on. Here's our teapot. Glorious. I hit the space G to zoom in onto the selected item. And you can see if I turn on points, there's really not that many points because it's a B-spline patch. So we're going to do the same trick that we did in our forest. We're going to drop down a scatter SOP. And now you can see I got 5,000 points to attract to. Let's change that to 2,500 because that's a bit quick. Okay, and I'm going to change the visibility back here. Nothing is still going to happen. That's different. Reset. Let's zoom out. The particles are going to go everywhere because I haven't specified the forces. So that's the next thing to do. I'm going to right click and type point SOP. Now, the point SOP is probably the most used SOP in Houdini, And it kind of makes sense because a lot of stuff that you do in visual effects and even in modeling has to do at the point level. So I'm going to click on the points up, and I'm going to go to forces. And you'll see that there's the top three guys is what we're interested in. And when you see the word keep, it means basically whatever is coming in from the input context, we're not going to do anything to. But I want to change this to add radius. Now what does the add radius do is, again, let's use that analogy of the Earth and Pluto, the gravitational force. I got my camera set up on Earth. Do I really care about Pluto? Do I really care about those gravitational forces on Pluto? Probably not. Do I want to waste my CPU cycles on calculating that? Definitely not. So what I'm going to do is I'm going to say, what is my simulation cutoff on radius here to calculate these particle forces? And the sphere was a radius of 1. The teapot was a radius of, I believe, 2, 3 across. So that's basically, 3 plus 2 is 5, 6, 7. If I even change this to, let's say, 30, way more than I'll need. So anything way up here we're not going to calculate. We're just caring about calculating in this area. Okay, I'm going to skip this guy for 1 second and go to radial force. Now, I'm going to add a radial force. So I'm saying how strong is each of those points going to be attracted to those particles are going to be attracted to. And let's try 12 to start with. Okay, and see how it works. So the last guy is this keep force scale. And basically it's a force multiplier that basically you could kind of think of the ease in and ease out of forces. And by default, I'll just start with 0.5. This is kind of like our fine tuning. We'll play with this as the simulation goes. And now let's run this simulation. So I'm here, I run it. And yeah, I see particles and they're not even going up. They're kind of like sucked to each other. And the reason for that is in the attractor. Let's look at this attractor one more time. You'll see here it says attractor use all points. So think about it. I got this teapot, which is kind of like a sphere. And right now with all points, it says each of those points, those 500 points that we created, or I think it was 500 that we created, or sorry, 2,500 points, is going to be attracting each particle. So basically everything's getting canceled out. If I switch this to single point per particle, now what's happening is saying I'm going to pair 1 point on the teapot to 1 particle, and that will be the only attraction. Now let's see what happens. Okay, we're starting to get them coming back, but the problem is now we're like in space. There's no drag. So I'm going to just go right-click here and say drag. Let's give it a little friction. And lo and behold, I'm starting to get my teapot. Way cool. Okay, now I'm seeing a couple things I don't like. One, it's really hard to kind of see this teapot because the particles are constantly being emitted. So let's say after 50 frames, I want to shut off particle emission so I could just see the teapot. How would I do that? And the answer is I would go back up to my source and I'll go to the birth tab. You'll notice that there is this guy called constant activation and impulse activation. Constant activation is creating particles per second, and impulse activation is creating particles per cook, which for now you can think of as per frame. I'm going to turn off the constant activation. These activations are Boolean flags, so 1 means true or on, and 0 means off. And I just kind of like to set this to 0 too. So I got impulse activation, and let's put in an expression. $NPT, which stands for the number of points from the particle emitter. Remember when I showed you earlier that the sphere had 42 points? Let's toggle here. Lo and behold, that's what it's evaluating to. Okay, so now I'm creating 42 particles per frame. Okay, but I want to turn it off after 50 frames. So all I'm going to do is, you're already familiar with $F. I'm going to create an expression. If the frame number is less than 50, then evaluate to true. It's true. And emit particles. If it's 50 or greater, it's false and stop. So let's see what we got now. You go to frame 50 and they turn off, and now they start to emit and become the teapot. Okay? Now, the only thing I like is I like this to be more steady state, to have more definition of the teapot. So I'm just going to go up, and remember in the points up under forces, I said it's kind of like your fine tuning. So sure enough, what I'm going to do is I'm going to change this to, let's say, 0.2. And now, lo and behold, say it's better. Let's reset this so you can see it from the beginning. And there's our teapot. Way cool.